Okay, so hi guys, my name is Sujudi and I'll be doing free response question 4 from the 2019 AP Chem test. Okay, so a student is doing experiments with CO2. Originally, a sample of the gas is in a rigid container at 299 K and 0.7 atm. The student increases the temperature of the CO2 in the container to 425 K. So part A asks, describe the effect of raising the temperature on the motion of the CO2 molecules. So to answer this question, we could use the root mean square velocity formula, which we learned in 5.3. And the formula basically just measures the average speed of particles in a gas. So the formula is the root mean square velocity is equal to radical 3RT over the molar mass of the gas. So just as a side note, the molar mass has to be in kg over mole, and that R is 8.314 joules per mole Kelvin. So using this, you could see that if you increase the temperature, you also end up increasing the speed of the CO2 molecules. You could also see this relationship through the kinetic energy formula, which is just 1/2 mv squared. So if you end up increasing the temperature, you also increase velocity. So if we were to answer this question, we'd say that the average speed of the CO2 molecules increase as temperature increases. Okay, so for part B, it says that calculate the pressure of the CO2 in the container of 425 K. Okay, so for this question, we could use the different gas laws that we learned in 5.1. So if you remind combined gas laws, that gives you the majority of them, which is P1 V1 over T1 equals to P2 V2 over T2. So just as a review, Boyle's law is PV equals to PV, and then PT over PT is Lusak's law, and then finally VT over VT is Charles' law. But there's also another law called Avogadro's law, which is V1 over N1 equals to V2 over N2. But for this question, we really just need Lusak's law, so P1 V1 equals to P2 V2. So if we substitute the values, we have 0.7 atm over 299 Kelvin equals to P2 over 425 K. And if we solve for P2, we get 0.99 atm, which is the answer to part B. Okay, so moving on to part C. Part C says, in terms of the kinetic molecular theory, briefly explain why the pressure of the CO2 in the container changes as it is heated to 425 K. So for this question, the kinetic molecular theory is explained in 5.3. So we learned 4 different aspects of it. So 1, the volume of individual particles is assumed to be negligible. 2, particles are in constant random rapid motion. 3, collisions are elastic, which means that no kinetic energy is lost. And 4, pressure is due to collisions with the walls of a container. So we know for this question that as the temperature increased, the pressure increased from 0.7 atm to 0.99 atm. However, the reason why this happened is because of the last part of the kinetic molecular theory, which states that pressure is due to collisions with the walls of a container. So because we know that the container is a rigid container, we can say that the increased temperature resulted in increased velocity, which resulted in more frequent collisions that also occurred more forcefully. And this all in all resulted in increased pressure within this rigid container. So if we were to summarize that, we'd say faster moving particles collide more frequently or forcefully. If you say forcefully or frequently, you'd get credit. With the walls of the container, thus increasing the pressure. So for the last part, part D, it says that the student measures the actual pressure of the CO2 in the container at 425 K and observes that it is less than the pressure predicted by the ideal gas law. Explain this observation. So from 5.1, we know that the ideal gas law is PV equals to nRT. So 5.1. And we also learned certain aspects of real gases in 5.3. So the ideal gas law actually assumes that the gas molecules only interact with elastic collisions as per the kinetic molecular theory. So, but real gases have attractive forces that make them cluster together, which makes them exert less pressure than predicted by PV equals nRT. So the real gas ends up exerting less pressure than is predicted by the ideal gas law because it's a real gas and not an ideal gas. So for this question, we would write that the attractive forces between CO2 molecules result in a pressure that is lower than predicted by the ideal gas law. So yeah, that's how you answer all 4 questions. Each of them are 1 point each for a total of 4 points. So yeah, I hope you guys are all doing okay, and yeah, good luck on the AP Chem test.